To approximate square roots to rational number equivalents, the idea is to arrange them on a number line in between two known perfect squares. So if I'm looking for the square root of 12, well, I know that the square root of 9 is equal to 3. And I know that the square root of 16 is equal to 4. So the square root of 12 is somewhere between the square root of 9 and the square root of 16. So if I wanted to, I could take 16 minus 9, and that would get me 7. And that would tell me that there are 7 perfect squares in between these two. So 1, 2, 3, 4, 5, 6, 7. So I could do this is the square root of 10, 11, 12, 13, 14, 15, and I guess that is the 7th one. So if you really wanted to, you could look at all these different square roots as existing between 3 and 4. The square root of 12 is a little bit in the middle. It's a little bit less than half, right? I've got 3 on this side and 3 on this side. So this is around 3.5. So the square root of 12, I could say, is a little less than 3.5. So maybe I'll say it's 3.4. If I wanted to maybe guess, I would maybe even say in between another decimal, I would say 3.45, like maybe in between these two. So for me, this would be a good estimate. So when I estimate, I'm going to use a wavy equal sign because I don't know. And I know that I'm immediately approximating this right now. This is not an approximation. This is a real number. But it's an irrational number, so its decimal equivalent will go on forever without repeating. So as soon as we truncate it, we have to use a wavy equal sign because we are now approximating the value of this to equal 3.45. We'll do the same thing with the square root of 22. We will try to find an approximate decimal value for it. So we'll look at the two perfect squares that are located nearest this. We have the square root of 16, which is 4, and then the square root of 25, which is 5. So I know that the square root of 22 is between the square root of 16 and the square root of 25, so it's between 4 and 5. And it's going to be closer to 5. So if I take 25 minus 16, that's going to get me 9. So that means in between these two square roots, there are 9 others. So 1, 2, 3, 4, 5, 6, 7, 8, 9. If I wanted to do that, I could do 17, 18, 19, 20, 21, 22, 23, 24, and then there's a square root of 25. So if I really wanted to just eyeball these, I could say that all these square roots do line up in order between 16 and 25. The square root of 22, if I were to look halfway, I have 1, 2, 3, 4, 5, 6, 7, 8. So we could say that half of them would be on the upper side of 4.5 and half would be on the lower side. This one that we're looking at, the square root of 22, is a little bit further ahead of that. So this is maybe 4.6 in here. So if I wanted to, I could say that maybe between 4.5 and 4.6 would be, or this is 4.7 on this side, so maybe the square root of 2 is a little bit closer on here. So somewhere in between this range, it would be a good estimate for me. So maybe I would say 4.65, halfway between 22 and 23 maybe. So in order to estimate these, you definitely should be able to get to one decimal place. The second decimal place is a little bit more of guesswork. But the idea is you should be able to line them up between two perfect squares and be on the correct side of the halfway point.